NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. Greetings to Tech Talk 131. Today we'll be discussing how to increase the current output of the JAMECO Adjustable Dual Power Supply Kit, JE215. We're going to do that by applying two transistors, an NPN for the positive side and a PNP for the negative side. These transistors will act as the current conduits for the power supply. But first, let's build a proof of concept. Let's go there now. This video is going to start out a little bit different than any of the other videos. We're going to begin with a proof of concept. A proof of concept is how you prove an idea that is feasible and manageable and can be produced. So what we want to do is convert the JAMECO dual adjustable power supply that we created in the last couple of videos into a 5 amp dual adjustable power supply video. But currently the JAMECO only put out 1 amp. The LM317, which is the side we're going to do the first concept on, can put out only 1 amp. What we're going to do is convert it and be able to put out 5 amps by adding one part and cutting one trace. And so we're going to prove that right now. I'm going to turn on this right here is your IC current. This here is the voltage dropped across the base emitter minus 0.6 volts that is used to bias the power transistor. Here is our varactor, which we're going to turn on. It would help if we plug it in, I guess. So we plug it in. So we're going to kick it up to 120 volts. And as you can see right now, we're drawing 5.8 milliamps through the IC current and the transistor. This one right here. And we're dropping 6 volts across the output. I'm going to adjust the output, prove that it's adjustable. And I've increased it. To 9.3. So if you add 10 volts output, as you can see, it's a nice smooth DC output. So the proof of concept is good. So now we can move on. I'll show you how to do this, how to select your transistor, power transistors for the NPN and for the PNP, and actually how to get the heat sink and everything you need to make this a usable power supply. Thank you. This is our block diagram that we'll be utilizing. We have our transformer converting the AC 120 to 24 volts peak. The rectifier makes a pulsating DC. Then the filter, which completes the filtering of the pulsating DC that feeds into the regulator. The regulator here feeds into the load. This transistor here is what we're adding. This will be our source of the current. It'll sink all the current. And then our LM317T is going to replace the Zener diode. And we'll just have that right there. Okay. Now, as you'll recognize this is the schematic of our JAMECO power supply. This is where we're going to cut the trace right here. We're going to add the power NPN power transistor right here. The base is going to come off R2, feed into the base. The emitter is going to go to C3, just past the slice of the trace. And then the collector is going to come off for CR1, go right into the collector. We'll have a heat sink on this, and we'll show you how to mount that and everything as we go along. So let's do it. Okay. Now we're going to look at where we solder our wires that interface to the power transistor. This is looking down on the board, component side. This is actually C1, the positive voltage supply. Here is where you would solder the wire that's going to go to the collector. The next is where the base is. That's where you'd solder to the base. Here, this red area is where you cut the trace to isolate the output of the LM317 from the output of the positive voltage supply. And here's where you solder the emitter. Okay, first thing you want to do is cut 3 wires the same length, 18 gauge. 10 in the wires, strip them and tin them about 1/4 inch. And that's what we'll do right now. All 3 wires, the one for the base, which is right here, the collector, which is right here, and here is the emitter. You can see right here where I slit the trace, cut the trace, and then I measured to make sure there was no conductance from either end. So now the LM317T is isolated from the positive lug on the output, and it only feeds the base of the transistor, which is going to be the current medium for the power supply. Okay, as you can see, we've got it mounted. If we were putting this in a case, we'd do a lot better job, but here we got the collector coming off this run here, or this trace. We got the base coming right out of the output of the LM317T, and then the emitter is going into the trace that is the output of the positive side. Now we're going to test to see if our concept works. We're going to start with a low current. We'll do 10 volts with a 1,000 ohm resistor as the load. That will make 10 milliamps. This meter here will measure our output voltage. This meter here is hooked in series with the resistor. So we'll measure current. It's on 400 milliamps. The variac will supply our AC power. We turn the variac on, kick it up to 110 volts according to the meter. And look at that, we have 10 volts out of the power transit, out of our power supply. We have a 10 milliamp current being flown through. It's steady. This is not getting hot. The only way the current can get out at all is to travel through the transistor. So the LM317T is putting out voltage to the base of the transistor. That voltage drops across the BE, voltage BE junction, turning the transistor on, dropping 0.6 volts because it's silicon transistor, NPN. And we're getting our current and our voltage up. So it works. Fantastic. Okay, we got it set up for 10 volts, 5 ohms, which will make 2 amps. The LM317T will go down in thermal shutdown if it exceeds 1 amp. So if our experiment here doesn't work, it will shut down. We'll get no voltage out. I've got this meter right here hooked in series with the 5 ohms. I'm going to measure the 2 amps with this. I'm in the 10 amp range. I'm on 10 amps here, DC and AC. This is my voltage out. We'll measure the voltage out. We're going to turn the variac up to 120 volts and let's see what we get. Didn't work. That's probably because the transformer doesn't have the power. Okay. Nothing good, huh? You may be asking yourself why the circuit worked at the low current, but not at the high current. The answer is an apparent power. Apparent power is the true power the circuit needs to actually energize the circuit to make the circuit work. So our transformer needs to supply enough energy for a 10 volt, 5 amp circuit to work. Now, apparent power is just your voltage times the current. So 10 volts times 5 amps is 50 watt. So it's 50 volt amps. Let's look that up and see what our JAMECO T1 current transformer can put out. So we go to our manual, we look that up. It's 29226. We go to the JAMECO website. We type that in. Here is our current transformer we have. Scroll down. And we can see that the power rating for this transformer is just 25.2 volt amps. We need 50 volt amps. That's not going to work. So we need to find one that'll produce 50 volt amps. I have one that I found. Let's look it up. The part number is 102121. Here it is right here. It's a 12.6 volt center tap. That's exactly what we need, but it supplies 4 amps at 117 volts AC. So we'll scroll down. We need 50 volt amps. The power rating for this transformer is 50.4 volt amps. This will work. This will drive 5 amps at 10 volts through that resistor, power resistor. So I ordered it. I'm waiting for it to come in. Once it comes in, I'll install it and we'll make a new video. I don't know how long it's going to take. Okay, thank you. That's it. Here at Lab Rats Engineering, NextPCB is our one-stop solution for PCB manufacturing, PCB assembly, and DFM analysis. They offer a wide range of high-quality PCB services, including multi-layer HDI, flex, rigid flex, and metal core PCBs. NextPCB also provides complete turnkey PCBA services from component sourcing to assembly and functional testing, ensuring precision, reliability, and fast turnaround, with express options available in as little as 24 hours. What I really like is their professional support, fast shipping, and consistent build quality. Their one-on-one engineering service also helps ensure your design is optimized for manufacturing. If you're getting started, NextPCB offers a $20 discount on your first PCB order, which is essentially enough to get your first PCB made for free. Use NextPCB as your comprehensive solution.